Hi, everyone. Welcome. Today is day 3 of this lesson, Keeping It Real, lesson 4, Keeping It Real. We are on page 62, activity 4.4. So as you can see here, for the do now, what we just did was we did what Ariana and Heidi were doing as well as the worked example. So, and we kind of did this in our way. Please take a look at what Ariana and Heidi were doing. It's basically what we're doing, just notated a little bit differently. I just feel like the steps are a little bit long when you do it that way. So we're going to condense things just a little bit. So you look right here, the square root of 18 a squared times 4 square root of 3a squared. All right, so and it was noted that inside the radical, they do have a term for inside the radical. We call that the radicand, not the radicant, the radicand right here. So if you look at 18, this is going to, we can split it up into 2 times 9. We could split up the 9 3 times 3. So we're looking at 2 times 3 times 3. That is a prime factorization. So we're looking for doubles, right? Because we want perfect squares, which are 2 of a kind. And so we notice that 3 times 3, which would be 9. We know the square root of 9. It's 3. So that's why there's that 3 right out here. Okay. And then the a squared, we know the square root and the a squared would count, the square and the square root would cancel out. And so all we're left is with the a. Or if you want to go, you know, a times a, right? And then that's one group of 2. So that would be our perfect square, which is just a. So that's this part right here. And then if you take a look at the right-hand side, 4 was already outside, so you don't have to do anything with it. The square root of 3 doesn't have any perfect squares in there, so we're just leaving that as square root of 3. And then the a squared, just like this other a squared, that goes out here. So now when you're multiplying 2 radicals, you're going to multiply the outsides and multiply the insides. They play separately. Okay, so the outsides multiply with outsides, insides multiply with insides. And what do I mean by inside and outside? My inside of the radical and outside of the radical. So that's how I think of them. So the 3a and 4a, if you notice, I shaded them purple. So that is 12a squared. So I multiply those guys, which would be 12a squared. And then we multiply the inside, which would be square root of 2 times square root of 3, which would be square root of 6, right? Just like I like to think of them like fractions, you know, like how with fractions you don't have to worry about like common denominators or anything. You just multiply them. Same thing with the radicals. You don't have to care about whether they are the same kind of radicals or different kind of radicals, just that they are radicals, and then you would just multiply them. The only thing about that is you got to make sure that they have they're the same root, right? If there's a square root and a cube root, those would be a little bit different. So you wouldn't be able to add those up. So just make sure that they're both the same root, right? Square root or cube root or fourth root, what have you. But that's what we're looking for. And I like to simplify them first. Some may ask, well, couldn't you have done it like where you multiply the insides first now? Yeah, you could totally do that. So if you take a look at what Ariana did, where's my draw? Ariana had done that first, right? She multiplied the insides first, so 18 times 3, which was 54, right? You would have gotten 4 root 54a to the 4th, right? So same thing here. So if we were to start right here, the 4 would still remain outside. The 54, well, let's see. Well, what times 4 is 54? Well, we know it's 18 times 3, right? So it'd be 18 because that's how we got 54. And then 18 is 9 and 3. And then if you notice right here, nope. It's like, wait, that's 9 and 2, right? 9 times 2 is 18. And then 9 is 3 times 3. And so notice here, the only thing that we have a double of is the 3s. We do not have the 2 and the 3. That's separate. They don't have any perfects. There's no double for that. So the 3 would come out. So that'd be times 3. And inside the square root, we would have the 2 times the 3, which is 6. And notice this was a to the 4th. So that's a times a times a times a. So how many groups of 2 do we have? 1, 2. Right, so that's going to be a squared outside. If you notice, oh, I didn't finish that. 4 times 3, 12. So 12a squared root 6. Notice that that's exactly what we got over here. So I don't personally like doing it this way just because I have to deal with bigger numbers. And I'd rather not have to do that because I have to simplify them anyways. So I like to simplify them first and then multiply. But either way you like to do it, it's up to you. And then for the next one thing to note, please make sure you take a look at this. All this is saying is that if you have a fraction in the square root, so like for example, the square root of 3/4, let's say, right? This is the same thing as say we could just split up the square root. So the square root of 3 divided by the square root of 4. It's just the same thing. So it can go, it's interchangeable. Okay. So if we take a look at this problem right here, which you notice right here, I did put the circle or I did group together the two square roots, right? So we are dividing. So we can see, okay, well, what can we cancel out? Normally when we divide, we try to see if we could cancel out things. This is that. So if you notice, we could cancel out the a squares, right? Because a squared divided by a squared is 1. And then 3 goes into 18 6 times. So it simplifies down to be square root of 6 over 4. Why is it over 4? Because remember this 4 is by itself outside of the square root. So we don't need there's nothing to cancel it out with. So that's what that's going to be. And some of you guys may ask, well, what about the 6 and the 4? Can we cancel those out? Would that be equal to square root of 3 over 2, right? And so what I always like to do is I always go back to my calculator and be like, okay, let me try. So if I try the square root of 6 and we get out of that and then divided by 4. So if these are equivalent, they should equal the same number, right? So let's try that. So we got the square root of 3 and divide that by 2. And if you notice right here, they do not equal the same thing. One is 0.6 and some change, and the other was 0.8 and some change, right? So yeah, they're definitely not the same. The reason being, this is not 6. This is the square root of 6, which is something completely different, right? So it looks like it's 6, but it really isn't. Okay, it's not a 6. It's just in disguise. All right. So that's how that would go. And they have it worked out here for you here. And notice they got the same answer that we did. 3 days. All right, so going on to the next one, we're going to take a look at Jackie. So Jackie made a mistake, right? Made a mistake. And if you look here, what did Jackie do? It looked like Jackie was canceling out the b's, right? Because they're both under the root, right? They both are under the radical. And so then you'd have no more b and c on the top. And then you just have one b and one c left. And then so your answer, and we know the square root of 25 is 5. So it's 5 divided by the cube root of BC. And you're like, well, what's wrong with that? If you were in class, you would know, hopefully. So we noted that, remember, so this was the hint. I might have used other examples for other classes, but pretty much this. The square root of 4 divided by the cube root of 4, would that equal 1, right? And a lot of you guys were like, no, because the square root of 4 is not the same as cube root of 4. They're different numbers. So that's the same thing here. You can't just cancel these out because one of them, the top one is a square root and the bottom one is a cube root. And if you recall, I did not say they're under the same square root. I said they're under the same radical or under a radical. Maybe I should rewind to see if I really said that. I'm pretty sure I said that. They're under a radical, which is not the same, and it's not the same radical. They are two different kinds of radicals, right? So this is going to be, so one's a square root and one is a cube root. So therefore, we are not able to cancel out the b's and the c's. It would just be literally all we're doing is just the only thing we can simplify is the square root of 25. So our final answer would be 5 root bc over a cube root of b squared c squared. That's it. That's all we can do. Okay. Now the question was, I don't know if you noticed, but in the fine print, you saw that there's no equal to here, right? Because remember, normally when we had restrictions, we were like, oh, greater than or equal to 0, because it had to be non-negative. Well, why is it specifically saying it has to be positive? Why can't it be 0? And so some people were thinking about this and came up with different theories, but ultimately it came down to, well, let's try it. What would happen if B and C were equal to 0? What would happen? What catastrophic thing would happen that they would not even include that, right? And so we included our 0 for B and C. And if you notice, the top just become 25 times 0 times 0, which is 0, right? And 0, the cube root of 0 is just 0. So 0 divided by 0. And if you try that in your calculator, you'll notice. What will you notice? Well, let's go down. Let's see what we'll notice. 0 divided by 0. Yeah, undefined. It doesn't work, right? The calculator cannot divide by 0. This was the whole Y2K issue as well. But yeah, you can't divide by 0. Because how many times does 0 go into 0? Like, I don't know. Like if we remember earlier, we did 18 divided by 3, right? Or 18 divided by 6. What was it? 18 divided by, yeah, 18 divided by 3. And we said 6, because 3 goes into 18 how many times? 6 times. Well, how many times does 0 go into 0? Right? It's the same question, like I said in class. If there were 5 cookies and 0 people, how many cookies does each person get? And you're like, 0. But it can't be 0 because we have 5 cookies. So people can get cookies, but we have no people. So how many cookies does each person get? See how it doesn't make sense? There's no people. It doesn't matter at that point, right? But honestly, if you want to think about it, if you think about how many times does 0, like 5 divided by 0, it's honestly, I think it's infinite. Like the answer is infinity. But as you know, our calculators do not understand infinity, right? It can't compute infinity. So yeah, an infinite number of times. It's like 5 divided by 0. How many times does 0 go into 5? An infinite number of times. It's weird. That's what I think. That's my theory, my answer for that, right? The answer to nothing is everything. It's very philosophical. And the answer to everything is nothing. All right, so here we go. We just did a little bit of practice here. So we have, I don't know if you can see these very well, but again, I would try and do these on your own first. If you did not do them in class, or if you only did part of them in class, I would try it on your own first. And if you notice right here, so we got 2 times 5. Remember the stuff on the outside. You multiply with the stuff on the inside. Don't listen to me. Multiply the outside with the outside stuff and the inside with the inside stuff, right? So we have 2 times 5. This one technically has the coefficient is 1. So it's just 2 times 5, which is 10. And then the square root of x times square root of x times square root of x, right? And remember, we're multiplying, we're not adding. So that would be x cubed, okay? The square root of x cubed, all right? So then we have to ask ourselves, okay, if you notice right here, oh, x times x times x. I got one group of 2, okay? It's my x squared. And I know that a square root and x squared cancel out, and all I have is an x left, right? So there's my x out here. Notice I try to color coordinate them. Hopefully that helps. And what is left over is just 1x, right? Because that x doesn't have a pair, so sad, right? And so this is going to be square root right there. So square root of x. Okay, so 10x root x is our answer. Now, somebody may be like, well, what about the absolute value, right? Because isn't it a square root? Didn't you say, Miss Lee, that anytime we have a square root, we need to put in absolute values? And I'd be like, you're not wrong. Thank you for noticing. But notice right here, it says given that x is greater than or equal to 0. So if it's already given to us, we do not need to put in absolute value signs because it's given. Like they told us it's only going to be, there's only going to be positive x values or 0. So we're like, okay, good for you. I'm glad you were thinking. And then, so let's take a look at this one right here. Notice this is x, the cube root of x times the cube root of x. So that's actually x, k times, did I say x? I meant k. So k times k, which is k squared. So we got the cube root of k squared, and notice this too. There's no other numbers to multiply with, so we just stick it outside. It's already outside, so it just stays outside, right? And then let's take a look at C. So remember C, we are going to be distributing because we can't add square root of h plus the square root of h to the third power, because that's not the same square. It doesn't have the same number inside, right? The same radicand. So we can't do that. Or we rather can't do that. All right. So we're going to just distribute. So I try to use different colors here. So 7 times 3 is 21. And square root of h times square root of h is square root of h squared, right? We're multiplying here, remember? So, and we know that this square root and the h squared, the square of the root is going to cancel out. So all we have left is this h. Okay. So that's what it just becomes. And then same thing here. So in the blue, we got 7 times 4, which is 28. And the square root of h times the square root of h to the third power. So how many h's are we multiplying inside that radical? 4, right? So it's h to the fourth. And if you notice right here, that would give us 2 groups, right? So that would be h squared outside of the radical, all right? And then notice I put a box around them. Why can't I add them together? Because they're not like terms, right? Just like here, we couldn't add them together because they were not like terms. They're still not like terms, okay? So there we go. And D was a weird one. So we're going to come back to D. All right, so taking a look at E, notice N is on the outside. There's a lot of parentheses. You technically don't need all of them. It's just there to fool you, right? Because we're not adding anything. So we don't need to distribute anything because there's no pluses, there's no minuses, right? So notice that N is on the outside. So I'm just going to bring that down here because there's nothing else to multiply with because there's nothing outside. And then, notice that we are cube rooting both of them. So we're going to multiply the insides. So 4 times 2 is 8. So let's see if I could get some colors going on here. So 4 times 2 is 8. Then how do I get the n to the third power? So this n, does it look like the same color to you? It's all very pastel-y. So n times m squared is n to the third power, just like that. All right. And then we're going to ask ourselves, well, can we simplify this? And we're like, okay, n, 8, oh, sorry, not n, 8. 8 we know is 2 times 2 times 2, right? 2, 4, 8. 2 times 2 times 2. So that is my group of 3, right? So we know that that's just going to become, this right here is just 2. And then my n cubed, I just get that one group because the n cube and the cube root, the cube and the cube root cancel out. All I have left is the n, right? And then so now I have n times 2n. So, well, I mean, since I'm multiplying anything, I can put the n's together, right? So it's 2n squared. Notice that there are no more radicals because they all cancel out. They canceled each other out, so it didn't matter. All right. And then let's take a look at F. So if you look at take a look at F, this was originally, let me erase this guy because you can't really see it very well. So if you notice that they're all, it's a fraction inside the radical, right? So we can cancel those out. So the x to the fourth on top, if you have 4x's on top, 2 on the bottom, how many can you cancel out? 2. And you're just left with those 2 x's on the top. So I'm just going to be like, cancel. This just becomes x squared. And then that's why we have 4x squared over 1. Do you need the 1? No. When we were doing this, somebody said the 1, so we can. You know, it's not wrong, right? And then what's the square root of 4? Well, that's 2. The square root of x squared, just x. And the square root of 1, 1. So technically, we don't need the 1, so we could just write it as 2x. Now, some people, now where you're like, wait a minute, don't we need absolute values, right? Because this was a square root, which is even. You told us many times that we need to have absolute values in there. I'm like, well, yes, we do. And so the 2 is always going to be positive. Like you don't need to put absolute values around that, but we do need to put the absolute value around the x. Now the question was, well, could we just put the absolute value around the whole thing? Well, that's kind of the cheat to the system, right? Yeah, you can. Just make sure you don't do it when it's like a cube root, because that would be wrong, because cube roots can be negative. But these ones, when it is a square root, yes. Either way is okay. This is the one where it's 2 the absolute value, 2 times the absolute value of x. That's just more specific. Just kind of shows that you know what you're doing. You know what I mean? All right. Now, let's see here. If we go back to D. So D, kind of talked about it in the wrong way for my other class, one of my classes. So I do apologize for that. I will talk about it tomorrow. But here's a little heads up. So we do know, so the square root of a and the cube root of a, okay, if they're all multiplying, and I had said before, like, remember, like we can still, like, we should be able to multiply them. The question is how, like, what does that look like, right? And so let's take a look. So what I like to do is I like to change them back to exponents because this makes it a little easier to understand, right? So if I change it back to exponents, remember that a square root of a is a to the 1/2 power. That's the same thing. And the cube root of a is the same thing as a to the 1/3 power. So far, okay? And that goes back to this guy right here, if you remember. Remember when we have our exponent, which there's no exponent, which means that that's a 1. And then our index is on the bottom. Think of our index like the roots. And the roots, where are roots of a tree? At the bottom. So it's always on the denominator. And so what we're going to do here is we're going to think about, okay, so when I multiply, so my bases are the same, and I'm going to multiply them, which means that what am I doing with those exponents? I'm going to add them. I'm just going to put this in a different color so it doesn't look like it's actually part of the equation. We're going to actually add them. And if you don't remember that, because a lot of times I would forget, I'm like, okay, what was the rule for that again? So I just go with something that I know. So I'm like, okay, a cubed times a to the 2nd power. I know that's a times a times a, and then I got 2 more a's. So altogether that would be a to the 5th power. How do I get that with 3 and 2? Oh, I have to add them. So this kind of helps me remember. So I'm like, okay, now I have to add these guys. So what's 1/2 plus 1/3? I don't remember. Don't say 1/5. That is a common answer. Remember with adding and subtracting, we have to have common denominators, right? So this is where this comes in. So 1/2 plus 1/3. So I know that I could split everything into 6s. I like to think of pizza, for example. So if you eat a half a pizza, then a third more, then how much of the pizza do you actually eat? Right, the whole pizza? No, not yet. So that would be like 3 out of 6 pieces. Remember, I chose 6 because 2 and 3 both go into 6 when you multiply, right? So that would be 3 6, and then a third of that would be 2 6, right? So 3 6 plus 2 6 is actually 5 6, right? And we'll be like, yay, that's the answer. And we're like, no, can't be that answer, because remember they told us in the book it says answer in radical form, which means we can't have these kinds of exponents here. We have to answer in radical form. So we're going to use, again, this conversion. And so we're like, okay, the exponent is on the top. So it's a to the 5th power. Then what are we going to do with that? We're going to 6th root it. So the way we would say this is the 6th root of a to the 5th power. That's how you would say that. It's complicated, but that's how you'd say that. All right. So this is the answer. Happy days. All right, moving on. So we're taking a look at Grace, Diane, Ron, and Sheila. And if you notice, we are now adding and subtracting radicals. And so Grace and Diane did a great job. Like, they get a thumbs up. But Ron and Sheila, sad days, they get a thumbs down. So let's see why. We take a look at Grace. Okay, I hope you paused. You saw why, right? Okay, so if you take a look at Grace, we have the 2 square root of x plus 6 square root of x is equal to 8 square root of x. And for all the things that we talked about today, yeah, if they have the same, just like how we do with polynomials, they're like terms, right? That's what that's going to be. So notice that the square root of x does not change. Okay, since the 2 on the left have a square root of x, we just want to know how many square root of x's do we have? We have 8, so it's 8 square root of x's. Okay, so same thing with Diane. Notice it is exactly the same, right? The exponent on the x is the same. The cube root is the same. So the index number is the same. All that's the same, right? And so the only thing that we're changing is actually just the coefficients. Just very much like how we would do with regular like polynomials. So if it was like 3x plus 2x minus 4x squared, you're like, well, which ones are my like terms? the 3x and the 2x, right? So we would get 5x minus 4x squared. Notice you did not say, oh, 5x squared, right? Because we're just adding up the x's, right? So this is, what is 3x? What does that actually mean? Just means x plus x plus x, right? That's 3 x's right there. Well, what is 2x? Well, that is x plus x. Remember, we're adding these. So it's just 3x. So we have x plus x plus x plus x plus x. So how many x's are we adding? We have 5 x's. That's if you remember way back in the day when we talked about, that's what that means. So instead of writing all of this, x plus x plus x, we just say, okay, we're just going to say 5x, okay, because we have 5 x's, right? Because it's the same thing as 5 times x, which is 5 groups of x, 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 x. So there we go. That's what that is about. And notice that and x's are not the same as x squares, right? So the same thing here, they have to be the same. If they're not the same, you can't add them together. And if you notice, that was Ron's issue. So Ron, poor Ron, right? He's like, but they both have x's. And we're like, you're right, but what's wrong? They don't have the same exponents, right? And I say exponents meaning like the index number, right? The radical is not the same, right? So one of them, the index number is 3, so it's cube rooting, and the other one is there, it doesn't have a index number, which means that's a 2. So that one's a square root. Yeah, these are not the same. So yeah, can't do this. This is like bad days. You can't just randomly do that, right? It's like adding these two guys together. All right, so in Sheila, what did Sheila do? It's the same thing, like I suppose if we go like x plus y. What is x plus y? Like, oh, xy. No, we can't say that. It's like saying, oh, what's 3 plus 2? Oh, that's 6. No, hopefully he said no, right? Because what is that? That's 5. Okay, you don't multiply the two numbers, right? You add them, right? Same thing here. If we're adding them, we don't magically just multiply them together. Okay, there's always, math is not magical. It can seem magical sometimes, but it's definitely, there's no like, oh, you just magically put them together. It doesn't work like that. There's math behind it, right? But yeah, we don't just randomly put things together just to put them together. All right, so if we're adding here, you should still be adding here. But here you can't just all of a sudden be multiplying them. That's a no-go, right? So what would the answer be? This is just your answer because you can't simplify that any more than it already is. Same thing with Ron's, that is just your answer. There are no like terms, or I guess in this case, there are no like radicals. That's it. All right. So that's kind of answers all of those things. And so we're going to move on here. We're going to go down here. So we're on page 66. And so we're going to combine like terms if possible. So notice they still said like terms, right? And then we're going to write your final answer in radical form. And you don't have to force a radical. And so what is the square root of y minus the square root of y? And right now, if you have not already done all these problems, do them now. Okay, that's the best way to do them. Okay, for you to do them and not me to do them, right? So what is the square root of y minus the square root of y? And you're like, well, doesn't that just cancel out? I'm like, yeah, just 0. Done. And you're like, what? It's supposed to be in radical form. That is in radical form. It's just 0. There's nothing else. Yeah, so you would just leave it at 0. Is this part important given y is greater than or equal to 0? Yes and no. Does it affect our calculations? No, it doesn't affect our calculations, but it is being more precise. So it is going to help us to determine whether we need to put absolute values or not. Since this is just 0, there are no variables. 0 will never be negative. Yeah, it's just 0. Okay, and then let's see for B. So 9 root A plus 5 root B is, I was waiting for an answer. That's it. There's nothing else to do. So this is literally not simplifiable. This is as simplified as it can get because, so I should probably say cannot simplify more. This is it, right? Because square root of A and the square root of B, they're not like terms. Okay, so we just Leave it like that. And then same thing here for C. Let's take a, ooh, they're all square root of x's. So this is good. So if they're all square root of x's, then we got 2 here, 1 more here, and 5 more here. So it's just 2 plus 1 plus 5, just 8 root x. And remember that 1. Where's the 1 coming from? Remember that invisible 1 right there. If there's no number there, we assume that that's 1. Okay, and because it wouldn't make sense if it was 0, because then why put it in there 0, right? So that's it. 8 square root of x. Remember, you do not multiply them because it doesn't say to multiply, it says to add, just to clarify. Yep, I could read your mind. So here again, so these are all square root of h's, right? So square root of h here, square root of h here, square root of h, which means all we're doing is adding, subtracting the coefficients. So that's going to be 7 minus 4.1, which is 2.9. And 2.9 plus 2.4 is 5.3. So check it with your calculator. But I'm pretty sure I've done this like 3 times today, so I'm pretty sure I'm right. Or maybe 2 times today. And that's it. There we go. So hopefully these are a little bit easier than you thought it was gonna be. And so notice, let's take a look here. I'm gonna just do some analyzing. We got square root of t here, square root of t here, square root of t here. Ooh, but this is not square root of t. Should put that in a different color. All right, so I notice, now some people you may think, oh, well, why don't we just distribute it? You can. You don't have to, because what do you notice? That the inside the parentheses is the exact same term, like they're the same terms, they're like terms. So we can just combine them. So that's what we're going to do first. So square root of 3 root t times, what are we multiplying? Or not multiplying, t square root of t minus 8 to root t. I can't talk very well. So which would be negative 7 root t. And then plus 4t. Not 40, 4t. All right. And so this is multiplying. We're not subtracting, right? Because this is multiplying. We got the parentheses there. So it's going to be 3 times negative 7, which is negative 21. The numbers on the outside. Those guys right there. That's going to give me the negative 21. And then we have square root of t times square root of t. What is square root of t times square root of t? Square root of t squared. And then we have this plus 4t. Well, we know that the square root of t, the square and the square root are going to cancel out. So what do we end up getting? So negative 21t plus 4t. Oh, look, they're all t's now, right? And there are no more square roots, which means we can combine them together. So that's going to be negative 17t. Do we need to put absolute values on them? Don't have to, because it's already stated that t is going to be greater than to 0. So we're good. Good. All right. So here we go. This last one. That's it. We're done. Right? Because what do you notice? These are 2 different things. So here is square root of g, and this is cube root of g. They're not the same thing. We can't add them together. So it is just 5 root g plus 2 cube root of g. That's it. Can't simplify. All right. Now, I had told you guys this would be great to know. This is actually a good exercise. So this is the sum, difference, product, and quotient. So we want 2 radicals that either add up to 6 cube root of x, or when you subtract it, when you do multiply it, and when you do the quotient, right? So this is a good practice. This is actually quite interesting. So I would recommend that you try this. There's a lot of different ways to do it. Don't overthink it, right? You could do something as simple as, like, okay, for example, the sum, right? So, okay, 2 cube root of x plus what would give you a 6 cube root of x. I just wrote 2 because why not? I just tried it out, right? So you can set up 2, you could try 5, you could try 1, you could try 7 or whatever, but that if you want to sum, you probably want to stick with positive numbers, so don't try 7. Maybe that could be for our difference, right? So think about what that would be. And this is like, remember, product multiplying and quotient is when we divide. We're going to be multiplying 2 things here, right? So what would that be? Think about that. I think for me, I think the product would be the most difficult. I think quotient wouldn't be that bad. Anyways, that's my opinion. But, and I said right here, so to go over the errors, right? Error analysis, I would say take a look at the problem and then the answer. You don't necessarily have to look at, well, it'd be good to look at the work, good to analyze it, right? It's a different way of thinking about it, but I would recommend that you solve it yourself and then compare your answer. Right? All right, so you've paused and you've done it. Okay, so here we go. Let's try this out. So I'm gonna look at these answers first. Okay, so the square root of 4 and the square root of, so they just split it up, the square root of 4 and the square root of x, the square root of x squared. Okay, so that seems fine. And we know that the 4 is equal to 2 squared. Yeah, because 2 squared is 4. And so the square and the square root cancel out. So all we have left is this x, or this 2. So this is the 2 right here. Okay, I'll buy that. And then here we got the square root of, oh, this is just copying this down because it's the exact same thing. And we know the square and the square root cancel out. So all we have left is x. Ooh, and they did put the absolute value. Were they supposed to? Well, it was a square, so it's even. So yeah, this looks like it works. So I think 2A is correct. I'm trying to do a think aloud right now, okay? And then if we take a look at this one, ooh, look, they changed it to exponents. This will be interesting. So here we have 3x cubed to the 1/2 power. Okay, that's weird because this says 3. So this should be 3 as well. So yeah, this can't be right. Okay, so definitely there's a mistake here. Let's take a look here. So then from there, what would it be? Oh, let me just rewrite this. So we're saying, no, this is wrong. So 3, I'm going to kind of use their x cubed. That was right. And that's to the 1/3 power. So I'm going to distribute this guy. And so I notice this is going to be 3 to the 1/3 power. And then power to a power, remember you multiply. So that's going to be x to the 3 divided by 3, which is just 1. So I'm just going to write x. All right. Okay. So I would not normally write it like that. So it looks like this would be x and then cube root of 3. And oh, do we need absolute values? No, because we're using cube roots, which can't be negative. So we're good with that. All right. So far, one wrong problem, one right problem. So let's take a look at C. So if you look at this, let's see here. So they broke this up. So the 4th root of 16, the 4th root of x to the 8th power, and the 4th root of y to the 12th power. Okay, I could buy that. And the next one is, well, what's the 4th root of 16? Well, it's not 4 because 4 times 4 is 16, but we need like 2 more numbers. So that's definitely not right. So let's try 2 times, if you go 16. So 16 is going to be 4 times 4, right? And those 4s are going to be 2 times 2, 2 times 2. So I have one group of 4, right? One group of 2. You know what I mean? Sometimes I'm like thinking too hard. So this should, instead of 4, this should be 2, right? That, you can't see that very well. That should be 2, right? So there we go. So our answer would have been 2, and then we have the 4th root. I'm gonna put the 4th root out here. We have nothing left over because we used them all. Everything, like we used all the 2s, right? So nothing left over. So then let's take a look at this one right here. So we have 8 x's, and we want groups of 4s. We've got 1 group, 2 groups. So we have 2 groups. So that's going to be x squared. And we have no leftovers because we used all the x's. So, okay, nothing in there. And then we're going to do the same thing with 12. Well, if it's, imagine 12. So 12 divided by 4, because it's and 4s. So that's going to be 3. Do we have any leftovers? No. So which means I guess we don't need this guy. Just wrote it for nothing. All right. So, and notice there that they put the absolute value around all of it. Well, I mean, that's not wrong, but you technically, this x squared is always going to be positive. So you only need it around the y to the 3rd power, because that's the only one that has the possibility of being negative, because x squared will always be positive. All right. If you wrote it that way, that's fine. Well, if you wrote the 4, then that would be wrong. But if you wrote it where the absolute values between around the x squared and the y cubed, that's okay, right? But it's redundant, like we had said before. X squared, back remember when it was, I think it was Asia and Melissa, right? That was a redundant thing, because x squared is always going to be positive, so you don't need to do that again. So this would be your answer. So far we have 2 wrong, only 1 right. Okay, so hopefully this one's right. All right, so let's take a look here. Oh, they're using powers again. So let's see if they did it right. So they copied it down, right? 81 times x squared. And now they did it to the 1/2 power, which is what they should have done. Good, because there's no index number here, which we know that is automatically a 2. All right, so 81, the square root of 81 is 9, so that's good. And then the 2 times 1/2, just 1. So we just write down x. Ooh, look, they put in the absolute values. Were they supposed to do that? Yeah, because this was a square root, which is an even one. And it doesn't say it's like any given, like where x is greater than or equal to 0. So yep, we would need this absolute value there. So there we go. It's your answer. And then let's take a look at that last one. I have a feeling it's going to be wrong. I see a pattern. We'll see. All right, so they're using exponents here as well. So remember, the square root is the same thing as 1 to the 1/2 power. Well, the square root of 16 is 4. So I'll agree with that. So this 16 is 4. All right, and then it says x to the 4th, and then so 4 times 1/2 is 2. So yeah, there's that right there. We'll look at the absolute value in a little bit. Not sure about that yet. And then y to the 1/2, because remember that's 1. So this one should be to the 1/2 power, because that 1/2 doesn't just automatically just go away, right? It's still there. So that should be to the 1/2 power. So let's write this out. So it would be 4x squared. And then instead of to the 1/2 power, I'm just going to write square root of y. Okay. And the question is, does the absolute value go around the x squared? Is the x squared always going to be positive? Yes. So then we're good, right? So actually we don't need the absolute values, and this should have been to the 1/2 power or square root of y. Either way is okay. All right, so that would be our answers. I would go over those. I would make sure that you look over the homework for today. It's good practice, right? Good practice. And it's kind of like what we did right here for the talk the talk. And don't forget to do your exit ticket. That's also good practice. I did write in there some of the work that you would need, so you could check. And one of the answers maybe you could check. All right, bye.